Here they are given integral 0 to pi by 2, integral 0 to a sin theta, integral 0 to a square minus r square by a r dz dr d theta. So here variables we have z, r, d theta. We know that generally you observe this is limit from 0 to pi by 2 is nothing but obviously this is limit for what? Theta only, na? Limit for theta. Remaining you have a z and r. R is not a function of r. So obviously this is limit for z. Now it is a limit for r. Like this we have to find out the limits. Right. Now we have to solve the problem. First you observe here they are given dz. Na? So first I am integrating with respect to z. Later I am integrating with respect to r. And then with respect to theta. This is the procedure. Okay. So integral 0 to pi by 2, integral 0 to a into sin theta. Now here we are integrating with respect to z. While integrating with respect to z, r is a constant only, no? So treat as a constant only. Now r z quotient what you have here, r quotient is 1. So 1 into dz you can say, no? So 1 integration with respect to z is z only. Now limits from 0 to a square minus r square by a into dr d theta. Now integral from 0 to pi by 2, integral 0 to a into sin theta, r into upper limit if you are substituted, a square minus r square by a minus 0 into dr d theta. So constant you can take outside, then I will have 1 by a integral 0 to pi by 2, integral 0 to a into sin theta. If you multiplied r inside, then you will have ra square minus r cube into dr d theta. Now we have to integrate with respect to what? R. Integrate with respect to r. Okay. Now 1 by a integral 0 to pi by 2. If you are integrated with respect to r, a square is a constant only. R integration is r square by 2 minus r cube integration is r power 4 by 4. Limits from 0 to a into sin theta d theta. Okay now. Now 1 by a integral from 0 to pi by 2. This is a square by 2. Now if you are substituted upper limit, then I will have r square is nothing but a sin theta whole square. That is a square sin square theta minus here you have a, sorry, this is 2, and now a power 4 sin to the power of 4 theta by 4, upper limit is over, minus lower limit 0, here also 0 only into d theta. So now if I this one I can simplify, take a square by 2 outside, then you will have a by 2 integral 0 to pi by 2. This is a square into a square, a power 4 by a is nothing but a cube sin square theta. Now minus here a power 4 by 4 you have, a power 4 by 4, but a power divided by a outside you have, na? So a cube by 4 integral 0 to pi by 2 sin to the power of 4 theta d theta. From the Wallis theorem you can write this as a cube by 2, then this is, here you have 2, na? So 1 by 2, 1 by 2 is came, na? So pi by 2, even na? That is why pi by 2 we will write from the Wallis theorem, minus this is over. Now a cube by 4 is the LCM. In this case you will have 3 by 4. From 3 by 4 you can take 2 from 2, remove 2 from numerator and denominator, subtract 2 from numerator and denominator, then you will have 1 by 2. 1 by 2 is came, na? So you write in pi by 2. That's it. Now from this 2 what you can take common means a cube you can take common. If I take an a cube is common, then I will have pi by 8. This is pi by 8 minus here 3 pi by 3 pi. Here you have, you see what I have, 3 pi by 4 4 4, 4 into 4 into 4, 16 4s are 64. So you can take 64 is LCM, 64 is LCM, then a cube is a cube. Here you have 8 pi minus 3 pi. 8 pi minus 3 pi is nothing but 5 pi. So the answer is 5 pi a cube by 64. Okay now, is it clear for everyone? Thank you for watching this video.